guys, welcome back to my system design series, and in today's video we are going to explore the fascinating world of database, focusing on two concepts: transaction processes and analytics. You have probably heard about the word OLTP and OLAP, but do you really understand how they differ, why they matter, and how businesses use them in practice? By the end of this video, you will have the clear understanding of the difference between OLTP and OLAP and how this system impacts everything from real-time transactions to long-term business insights. So let's start from the basics. What do you mean by transaction processing? In the early days of business, a database entry often corresponded to a commercial transaction, a sale, a payment, or an order. For example, when you purchase a coffee from the cafe, there is a series of actions taken in the backend. Your order is processed, the money is transferred, and the transaction is logged into the database. And this whole process is called transaction processing. Transaction processing systems are all about real-time data. The core focus is speed, quick reads and writes. When a user interacts with the system, they expect the instant feedback, whether it is placing an order, updating an account, or sending a message. This system must handle numerous transactions in real time and usually with the low latency response time. Okay, let's take an example and understand it in better way. Think about your bank's mobile application. When you transfer the money, the transaction must be recorded immediately and you need feedback immediately, usually within seconds. The system works under the principle of online transaction processing, that is called OLTP. Okay, so let's get deeper into OLTP. This system deals with the small scale real time operations. So these are the 5 points which we are going to discuss about OLTP. Main read pattern. It usually have small number of records per query. Its main write pattern would be the low latency, random access of rights initiated by users. So who are the end users? So end users are like the customers who are using or interacting with a web or mobile app. And here the data always reflects the current state. For example, your current account balance in your bank's mobile application. Data volume. Usually OLTP systems deals with gigabytes and terabytes of data. So let's take an example. When you buy a book online, the system fetches customers' data and updates your purchase history in the backend. Each click or transaction is processed as a part of the broader OLTP system. Okay, so now let's shift the focus to the OLAP. OLAP is online analytical processing. It focuses on real-time transactions and is designed for the queries that analyze the data. And this is where the business intelligence come into the picture. Analyst needs to aggregate and summarize large volume of data to generate reports and insights. For example, let's imagine the retail company wants to know how much revenue each store have generated last month. This type of question doesn't need to be answered in real time, but requires scanning the amounts of historical data to calculate totals, averages, and trends. So let's talk about some of the key characteristics of OLAP systems. First is main read pattern. So here aggregating and summarizing large data sets, often reading large numbers of records. Another is it bulk imports of data through ETL, that is extract, transform and load. So it bulk imports of data through ETL processes or event streams. The users are internal analysts, business intelligence teams, and decision makers. The data reflects the historical data over time, often representing trends and events. OLAP system manages much larger data sets. They are in terabytes or petabytes of data. They are around terabytes or petabytes of data. So let's take an example. If you work at retail company and want to calculate the total sales for all stores for the past year, that is the perfect case for OLAP. The database will scan massive amounts of transactional data to provide sum of transactions per store along with other key statistics. Let's look at some of the typical queries. Analysts might ask questions like what was the total revenue of each store in January? Or how did our sales change after the promotion last month? Which products are commonly bought together in our stores? This type of questions often involve aggregate statistics like totals, average, and counts across large data sets. And this contrasts with OLTP, where we are more concerned with specific transactional data like a single sale or an order. So now we have discussed OLTP and OLAP. So let's see what is the difference between them. While both the system uses the same query language, their architectures and use cases are totally different. OLTP handles real time transactional data. Think of it like if the customer purchases any product or any banking transaction happens. While OLAP is all about analyzing massive data sets, helping businesses to make data driven decisions. OLTP requires low latency reads and writes while OLAP reads large data sets. Here the data is at present or current state, and here the data is historical or past. Okay, one second. Yeah. And this is all end user driven and it is analyst driven. Let's see how this system plays out in real life. OLTP. Imagine an airline booking system. Each time a customer purchases a ticket, the system processes the transaction immediately. For OLAP, the same airline might want to analyze booking trends over the last quarter. How many flight tickets were sold, which routes were most popular, or what was the average booking price was. While OLAP and OLTP systems have traditionally been separate, many modern organizations combine both into the single ecosystem and they do this through data warehousing, a system where OLTP data is moved to an OLAP database for deeper analysis. So here is how it works. Data collected in real time through OLTP systems. Regular ETL processes extract, transform and load this data into a separate OLAP system like a data warehouse or data lake. Analysts use OLAP system to run queries and generate insights. A real world example is Netflix. They use OLTP to manage users' accounts, subscription, and viewing history. But they also uses OLAP to analyze the viewing patterns of the customers, recommend content, and optimize their streaming catalog. Managing OLTP and OLAP together comes with a lot of challenges. This both the system have different performance and scalability needs. OLTP systems needs to handle high concurrency with minimal latency, while OLAP system needs to process large amount of data efficiently, often with the less latency requirements. Over the past few decades, the lines between OLTP and OLAP have been become blurred. Modern system often combines transactional and analytical workloads into a unified architecture. Companies are increasing the hybrid models that allows them to process both transactional data and perform analytics without having to maintain two separate systems. Cloud technology, in particular, have made this easier by providing scalable and flexible data processing solutions. Okay, so that was all about OLTP and OLAP. Okay, let's talk about data warehousing. In simple terms, a data warehouse is centralized repository where large amounts of data from different resources are stored and organized for analysis. Think of it as a specialized database that is optimized for running analytical queries instead of handling everyday transactions. Now, imagine a large company. It might have multiple systems that handles different parts of its business. For example, a website that handles online customer transactions. Then there would be physical store and inventory management system for tracking products in the warehouse, a logistics system which takes care of the delivery, and HR system which takes care of the employee data. Each of these is transaction processing system, that is a OLTP. These systems are responsible for keeping the business running day to day and typically involve frequent read or write operations with low latency requirements. However, when you need to analyze the data across different systems or run complex reports, querying this transactional database directly is not practical. You can end up slowing down or even disrupting your business operation. And this is where data warehouse come into the picture. A data warehouse contains a read only copy of data from all these OLTP systems, structured in a way that is optimized for analytical querying. So, what is the difference between OLTP and data warehouses? OLTP systems are built to handle daily transactional data such as order placements, sales transaction, inventory updates, etc. They have high availability, low latency, frequent read and write operations. Complex indexes are not needed because quick insertion and updates are the priority. Normalized database schema to avoid data redundancy and ensure data integrity. While a data warehouse is built specifically for reporting, analytics, and business intelligence. And here its characteristics are read heavy queries are common. Data is usually denormalized to improve query performance. Data is extracted from OLTP systems, transformed into the suitable format, and loaded into the warehouse. The schema is optimized for analytical workload, often using techniques like star schema or snowflake schema. A data warehouse is optimized for read operations, where OLTP databases are optimized for transactional workload. This is the core difference that enables you to run complex reports without affecting the performance of your core transaction systems. Okay, so now let's quickly touch the benefits of data warehousing. First is improved decision making. Analysts can query large data sets and generate insights that drives business decisions. With historical data in one place, businesses can spot the trend over time rather than just having the access to real-time transactional data. Second is optimized for analytical queries. Optimized for analytical queries. Data warehouses are designed to handle complex queries much faster than OLTP systems. They use special storage techniques such as columnar storage, which makes querying more efficient. They use special storage techniques such as columnar storage, which makes querying more efficient. Third is separation of concerns. By having dedicated system for analytics, OLTP system remains unaffected by the load generated by complex queries. Fourth is data Consolidation. All data from different part of the business can be combined into single source of truth, making it easier to generate comprehensive reports. And fifth is scalability. Data warehouses are built to scale horizontally and can handle massive amounts of data, making them suitable for large enterprises. There are wide variety of tools and technologies available for building data warehouses. Some of most popular options include commercial tools such as Teradata, Vertica, SAP HANA. Some cloud based solutions are Amazon Redshift, Google BigQuery. Another is Snowflake. Some open source are Apache Hive and Presto. If you want to know more about it, just comment down below. I will make separate videos about these all tools. While data warehousing provides significant benefits, there are also several challenges to consider, and some of them are data quality. The success of data warehouse heavily depend on the quality of the data that gets loaded into it. Poor data can lead to inaccurate analysis and decisions. Second is ETL complexity. The ETL process can be complex, especially when handling the large data sets. Managing the pipeline, ensuring data consistency, and optimizing the processes can be challenging. Third is the most important one is cost. Building and maintaining the data warehouse can be expensive, especially when using commercial tools or managing the infrastructure on premises. Cloud based options can mitigate some of the cost but still require careful management. Fourth is scalability. As the data grows, ensuring the data warehouse scales efficiently can become a challenge. Many companies opt for distributed storage systems or sharded database to handle this. Fifth is data latency. In some scenarios, having the real time data in the warehouse can be crucial. Managing the delay between when the data is generated in transactional systems and when it is available in the data warehouse requires careful planning. So this was all about data warehousing. I hope you have understood this all concepts in the depth. If you have any suggestions or any doubts, you can comment down below. And please make sure you are subscribing to the channel and make sure you like this video and share this video with all of your friends who are preparing for system design interviews. Thanks for watching.